All right, thanks for joining us. My name is Tanya Roberts, and thank you for joining our second webinar, API Design with Stoplight. So we'll cover just a few things that we did in our last webinar, so this will be a little bit of a review to begin with. So today we're going to cover off the rest of the platform. So in our original webinar, we covered off on design and some of the validation. Today we're going to go over the rest of the platform, including mocking and documentation. So today's takeaways are a bit like the last webinar, which is we want to have you really walk away with the understanding that API transformation really does start with good design. And design to scale is really only possible with the right tools. And really the whole point of the Stoplight tool is to involve more people in the design of your API so that more people can be involved with the design of your API and so that you don't end up designing something that no one wants. So let's just take a second to think about the API spec. And we just have just a few slides before we really get into the demo. So this should just take about 5 minutes or so. We think about what Gartner says of the importance of the API spec and everything that it touches. You can think about Stoplight really as the back end of this, is really the green piece, which is design. If I take just a second to also just to brag about Stoplight for a minute, we were just picked to be a cool vendor for Gartner for 2019. So if you have a Gartner subscription, I encourage you to take just a minute to look up Stoplight. But thinking about that API spec and the design piece, we can also think about the benefits of design first. And so I have 2 poll questions that we'll cover off in this webinar. And so this will be the first one. And so just thinking about the benefits of design, what are the benefits that you're looking to gain with API design? So I know that we only have a few people on the line, but if you could just take a second and answer this quick poll questions. When you think about API design, are you looking for cost savings? Is it speed of delivery? Is it better consistency? I know a lot of our customers tell us they're looking to look like more like one company instead of many business units. Are you looking to eliminate errors? Are you just looking to involve more people in design? Awesome. Thank you for answering that. I appreciate it. Now, thinking about that design and thinking about where we fit in, Stoplight really is purpose-built for that most critical piece of API transformation. There's really never been a piece for design before Stoplight came in, and we've always had sort of that designer, but now we're going to carry that conversation into really design management. Most people have some sort of IT project management piece for planning, and a lot of people have a tool around the build runtime of APIs. But now we're really starting to think about that category around API design management. And you're going to see in the future version of our product that's coming up just this next couple months, in May and June, that we're going to take that design piece a bit further and give you an ability to really look at all of your designs across your organization and have some governance and reuse of those designs. And so this is my last poll question. I just want to get a sense as we're going into the demo, you know, who in your organization is on our call and who you represent. What's really great about Stoplight is that we do have the ability to involve more people in that API process. So I appreciate you taking a second to answer the poll. So that is my last poll question. This is the last of my presentation slides. So we've got a chance to now look at the create process. We've done a little bit of validation in our earlier webinar. We will review some of that for anyone who's new. Now we're going to go into that mock, test, and document pieces of the platform. And if we have time at the end, we're actually going to give you just a little bit of a preview of our Explorer tool. We'll leave that up to Ross in the time that we have. So we'll focus on that today. And what I'll do now is we'll just pause for just a second here. And I'm going to let Ross get his piece ready. So Ross, you want to take it from here?
Thank you, Tanya. Give me 1 second here and I'll share my screen. Okay, great. And so just really quickly to recap on what we did on the last webinar, we took a quick walkthrough through the API design tool here in the Stoplight user interface. And as you can see here, and I'll close the little sidebar here, we have a few different views for each API specification that lives within Stoplight. We have the read view, which is the automatically generated documentation. We have the design view, which is the graphical form-based designer for the Open API specification. And then we have the code view, which is the raw specification. And this is the output of the specification itself. And this is typically what you see in other competing design tools. As part of the last demonstration, we also used the CRUD builder utility here for generating endpoints and operations for this API specification. So this is another very quick tool that can be used if you follow that typical CRUD REST pattern where you have an object that needs to have models that you want to support, a list of creation, retrieving these models. The CRUD builder is the quickest and easiest way to do that. We also support other things that are not necessarily supported by OpenAPI v2, such as a read-only view for model keys, and so there's a little bit of a benefit in there as well. We use the validation interface up here to both see the errors and the warnings that we received as part of the specification, as well as you can also use the cogwheel here to customize these errors. And then lastly, we used the version tool here to create a version of this API that is ready for release and ready for consumption by the API consumers. So now that we have a fully open API v2 specification, let's go ahead and create a mock server for this API spec, just to get a feeling for how it works. And so by mock server here, we really refer to just a virtual server for this API specification that will respond and feel much like this API if it were an actual API implementation. However, we're really just using this API specification and converting a virtual server for it. So there's no other business logic tied to it. There's no other development that needs to be done. And the real benefit for the mock servers that we see is primarily as a development tool where you can use the mock server so that multiple teams can settle on the API contract that exists in this API specification. And just from that specification alone, they can create a mock server, and the different teams, as they're waiting on the actual implementation to be built for the different parts of the application, can continue to use that mock server. So for example, you can have a front-end team and a back-end team. And while the back-end team is continuing to build out the underlying business logic for this API, the front-end team can use this mock server to get started laying the foundation for integrating with that API and that back-end application. And so there's other utilities there that can also be served as the mock server. However, typically the development tool is typically the most common use case that we see. And so to get started, under the servers heading here on the left-hand sidebar, we're going to create a new file. And in this case, I'm just going to call this mock. You do have the ability to create a mock server per API specification, or you can also create just one API specification, or sorry, one mock server, for all the API specifications. So we're a little bit flexible on how we manage that. So now I have the mock.prism file. You can also give a title and a description to this mock server if you'd like to for other users within your API project here. So I will say to-dos mock. Under the APIs section here, and I'll close the left-hand sidebar again, under the API setting, we're going to link in the API that we want to use. In this case, this is the main.oas2 file. I'll go ahead and give this a little bit better name. And so there are a few other options up here at the top. These are more advanced use cases where if you have an upstream URL, so if you actually do have an API implementation for this API, but you only want to mock certain endpoints, you can use a combination of these settings. So I could set a URL here and then dictate what methods or host names or paths should be routed to that upstream URL. By default, these will be fully mocked We do support a little bit more advanced use cases like that. So if you would like to mock only certain parts of the API specification while proxying the others to an actual API server, you do have the ability to do that. And I can also list more than one specification here if I'd like to. In this case, we only have the one API spec, but you can create, like I mentioned before, one mock server that responds for multiple API specifications. So if you have 5 API specs in this project, you could create a single mock server for all 5. So now we have our to-dos API linked in. Under the rules section, we now need to create a mock rule. We're going to apply it to the to-dos API that we created. So in the before section, and this is the most important part of this here, is before that we have a set of shared and common scenarios that you can use for running the mock functionality. And really, there are only 3. But in this case, for the before rule, for a mock server, we want to use the before mock scenario. And then similarly, for the after rule, we want to use the after mock scenario. And these are actually Prism scenario files that we have built into the application. And these control the mock functionality and for different aspects of that request lifecycle. So as a request goes into the mock server, the before mock scenario will validate the request, ensure that all security settings are set, really take a close look at the API specification and that request to ensure that it is, conformed with that API spec. And then on the after side is for the response. And so we validate that the response is correct based on, what is in this API specification, what's the JSON schema for this response for this endpoint. As well as we also set other options. There are headers set if there are validation errors found. So even if you are using examples that are written into the API spec, we still do validation. And so we do actually include headers if there are validation errors. And so it is important to also check headers for these mock servers to double check to make sure that both the request and the response is valid, conforming to the API specification. And so now we've created our mock rule. We've linked in our API. And so now we have the main.oas2 file, which is that to-dos API. We have the mock.prism server file. And every Prism server or mock server in Stoplight receives its own custom subdomain. So you can see this here. So I can go now to an endpoint that was listed inside of the API specification that I linked in. And now I get a fully virtualized response here. And I can take this domain, so this long string of characters with _prism.stoplight.io, and I can reuse this. We support both HTTP and HTTPS tooling. You also, in the user interface here, we also have the ability to serve this Prism instance locally. So you can run the mock server local on your machine. It does require that you install Prism, but if you do have Prism installed, it's very easy to install. That we have documentation for covering the installation process. You can run it locally here, running these commands. And so as part of a CI/CD pipeline, you can run this as part of a set of validation tests. So instead of mocking a server within your test application, you can use just an API specification mock server directly. Or you can also just host it locally within your firewall if you'd like to. So there's no limitations on how or where a mock server is used. But these are available in case there's any needed flexibility here. It's also important to note that for the mock server here, we will automatically respond with the examples that are set inside of the API specification. And if you'd like to make this a more dynamic response, you can use the __ dynamic query parameter, and this will auto-generate responses here based on that JSON schema. And so if you do not like the automatically generated the responses here, since these are sometimes a little interesting, just with the auto-generated text in some cases, and the integers and the timestamps won't necessarily make sense. It is recommended to use examples whenever you can. And so now that we have an API that looks and feels like the API specification that's created, we can now begin both the code generation process for this API specification and really start the development process. So as we build out this API specification, one thing that's important is just to make sure that what we're building, so the actual code living inside the implementation and this API specification stay in sync. And for this purpose, we have the scenarios testing tool here. And so under the testing header, I'm going to create a file here called just test. And one unique piece of functionality that's here for Prism and for Stoplight is the ability to link in an API specification. And so here I can select this main.oas2 file. All of the operations will automatically populate down here. And so I can go through and verify that I'm testing every single endpoint and operation that's part of that API specification. The other added benefit here is if I link in the API specification, since the response, the request structure is mapped inside of that API specification that includes the validation, includes everything that should be required, everything that's not required, the format of a lot of those objects, we can transparently validate that the contract that's set in that API specification, so how the API should look and feel, is being upheld. And so in addition to having a way for running just very lightweight testing, we can also validate that the API specification and that API implementation are still in sync, and that the contract that is set in that API spec is not being violated by that API server. And so for this use case, I'm just going to go ahead and generate a few tests here for the create to-do. Since this is a to-do server, I'm going to go ahead and just create a to-do, retrieve it, update it, verify that it was updated, delete it, and then I also want to verify that it was deleted, just to ensure that this whole kind of to-do lifecycle is correct and valid. And so for the last step here, I want to retrieve this to-do, but the last to-do is going to be a 404, hopefully. And so I'm expecting this to be a 404, so I will test that this is this last option here is a 404. And if I click the Create Scenario button, now we have a full scenario with all these steps posted here. And you'll notice that this is fairly similar to kind of a Postman collection, where this is just a series of HTTP calls that we're making to this API implementation. And by default, we've linked in the host field. So something that we didn't cover in the last webinar was that within the API designer here, we have what's called the environment section. So up here it's set to default. If I click on resolve, these are the values that are set in the environment currently. And so you can set and override your own values as well as set your own stages here. So right now we have default, staging, and production. However, you can also rename these. So if you'd like to have development, pre-production, production, or acceptance, production, you can certainly do that. And what this allows you to do is very quickly switch between the different stages. So if you want to run a test against your development server and then switch over to staging, you can very easily do that. And you'll notice now we're up here in staging. In this case, my variables are already set in the default environment, so I'm going to leave them here. But you'll see that we're using the host field here as well as the to-dos API key, which is this super secret API key that we're using for the to-dos API when we have to update to-dos. We also support private variables here. So if you unclick resolve, this is the private variables view for the designer currently. I don't have anything set in here. However, private variables are not stored within Stoplight. They're stored within the browser. So you can include things here such as API keys, session tokens, passwords that are specific to your user, and they will not be shared with anyone else that's in this project. And you'll also notice since we've linked in the API specification, we've already pulled in certain attributes. And so if we look at the $env, which stands for the environment, our host is pre-populated here from our environment that we just looked at. We've also pulled in an API key. And this is from looking at the API specification itself. We know exactly what the request structure should look like. And if I click on the test tab here, since we know exactly what endpoint we're hitting, what verb we're using, what the resulted output status should be, we can know exactly what the response should look like, where we have a name, completed, ID, all of the validations here, so that whether items are marked as required, if they have other validations, so in this case, an ID must be between 0 and 1,000,000, and also the formatting here, so the completed at, updated at, and created at values should be a date time format. If any of these are violated, you will receive errors here, and so this is, again, very important for ensuring that the API specification, that API implementation are in sync, especially if you end up using that API specification for other parts of that API ops toolchain. So for example, you're generating documentation, you're generating code, you're integrating with an API gateway. It's very important that these remain in sync. And so if I just go ahead and run this whole collection, which includes all the scenarios in it, looks like we got an error here. And if I go down to the output, you'll see we got a 403. So we're not authorized. That's because the value here does not have an API key. And so for that, I'm going to set the 123 API key. If I set it in one location, it'll automatically be propagated to all the other steps here. So if I rerun this, now I get a 201, which is what I was looking for. However, if I look at the test, I see one failing test here where the user is required. So I can look at the body. If I look at the test tab, I can see exactly what this response object should look like as part of that API specification. And I can see that the user object here is marked as required, and there is no user object here in the body. So what I'm going to do is swap back over here to the to-dos API, jump to the model, and just mark this user as no longer required, and then save that. And so the idea here is not that the correct action was to update the API specification, but just to understand that there is an issue here where either the API implementation itself, it could be a bug in the server, or the API specification, maybe the specification is outdated, and you no longer want to include that user object there. But that's being accounted for and surfacing these issues early and often, just to ensure that these are still in sync. And if we look now, we get a create to do, we got a post 201 with an output value status of 201, and the output validation contract succeeded. Now, if we look at the next step here on get to do, we'll notice in the past we're using something called the context, where we have this $.ctx, and then it's referencing a to-do ID, which is the path parameter that is set in the API specification. And so in many cases, what you're going to find is that as part of this, an API interaction, you can't just make standalone requests to this API endpoint. You need to include some other piece of data within here. And if you're talking to an actual API server, you do need to kind of interact with a specific ID in this case. And if I look at the body of the first step here, where we created the to-do, notice that there's an ID field. And so I want to reuse this field here whenever we run the subsequent steps. And so what I want to do is store this in the context of this scenario. And so in the captures section here, immediately to the right of tests, I can create a capture. I'm going to use the same path parameter as it's referred to as the API specification, so to-do ID camel case. And I want to collect the ID from the body. So I select the ID, I store it in the to-do ID, and now every time that we use the ctx.todo ID, this value will be substituted. So if I rerun this collection, now everything is hooked up. I can see I've got all passing tests. I can go and inspect each request and see what the tests were, what the body looked like. I can even add more tests in here. So if I'd like to add other assertions, so you know that when we go into update a to-do, maybe I want to set completed as false. And then when I retrieve that, I want to make sure that the output body status, completed, equals false, just as an example. And so you can add other assertions here. We also have the ability to link into a JavaScript script. and there's a little cheat sheet here. So you can use this for setting environment variables, and actually really anything that you can do here, either in the tests or the captures. Objects can be done in JavaScript directly if you prefer to work in JavaScript. You can also set different values in the request and response cycle here. So if you'd like to override something in the request structure, override something in the response coming back from the actual server, you can certainly do that here within the scripting. And now if I click on the Swagger OAS coverage, you can see, so on all codes, we have 31% coverage. On just the successful response codes, we have 80% coverage, where we did not do a full on the list to-dos, which we could certainly do. We also hit 5 endpoints. And as part of this run result, you can see all the values here. You can see the full time taken. And as part of the output body, so if you run this from the command line, so if you include this into a CI pipeline, you will see the full response output here, and that this includes every scenario that was run, the endpoint that was hit, as well as the request and response structure coming back from that, and the timing for that step. So there's a lot of great information here that can be used for timing and kind of a little bit performance and benchmarking tools as you're running these tests. So there's a lot of flexibility in how you use this structure, and this is just a flat JSON structure. So you can start cataloging these values and track these over time as you make updates to your API implementation, or maybe make updates to your API specification. And if you'd like for more information on how to link this into a CI pipeline, we have the trigger this collection button here, which shows how to run this from the command line. We also have a full page and a full section actually on CI integration in our documentation, specifically for Prism. You can also trigger these scenarios remotely. So if you'd like to have this run this exact same scenario that we're running here, but run it from our hosted Prism instance instead of using a local Prism, you can do that using this trigger by URL. And so this is another way you can run this on a cron job with a predefined set of hosts, just to validate that again, that the API specification, the API implementation, whether it's built out fully or as it's being built out, are still in sync. And so any other consumer of this documentation, or if you're using this for generating the API code, the SDKs, really anything that kind of flows from the API specification, which is, as we're seeing, is turning out to be a lot more. That you may be using this in your API management system, you're using this for your documentation, you're using this in your gateway. That a lot of subsequent items flow from this API specification. So ensuring the correctness and validity of this API specification is critical. And so now we've had the API specification. We have a mock server that we can give to developers and to partners. We can also use this as a validation tool just to ensure that the API responds the way we want it to. And now we have a full set of tests that run against the actual API server. When it's time to publish this documentation, either for review or for giving access to an external audience, we're going to use the globe icon here on the left-hand sidebar. And then from here, we can choose a domain. It can either be under the docs.stoplight.io domain if you're in our hosted environment. If you're running on-premise, this can include an internal domain for your organization. Or you can set a full custom domain here. So in this case, I'm just going to use the docs.stoplight.io subdomain here. I'm going to publish out the main.oas2, which is the to-do server. And you'll notice here that we have a lot of integrations and other add-ons available. So you can include analytics tools and integrations here. If you'd like to integrate with Google Analytics, Google Tag Manager, or even Intercom, so you can chat with your users. You can also wrap the published documentation and authorization. So if you want to have just a basic username and password, you can set these here. We also offer integrations with Auth0, which is a third-party authentication service, as well as the SAML single sign-on, with others coming soon. And then lastly, at the advanced section here, we have a section for redirects. If you'd like to redirect certain endpoints to another domain or another path. You can also include custom CSS, custom JavaScript. And then if you want to nest this behind a base path, so if you want to nest this behind your own domain under a docs or API docs base path, you can certainly do that. And once I've configured, I've set the authorizations if I need to, I've added any integrations I want. I click the build and publish button here, which is going to kick off the build process. And this varies depending on the size of the API specification. For something as small as this, it should just take 10 to 20 seconds. And you'll see here now that it's completed. Before I click and actually view the published documentation, you'll note that we also have the ability to download this blob. So if we wanted to take what's hosted here, so now I have the full API reference for that specification that we created. I can search on it. You can do the same thing locally or behind your own firewall. If you download the zip file here, and this will open up just the index.html and the contents that are being hosted by Stoplight if you use it to host the Stoplight. But you do have the ability to host these locally as well if you'd like to. You'll also notice from the documentation section here, we do have the ability to send test requests directly from the browser. And so I can send these here. This will be a 404. But just another way for consumers of your API to get a feel for the API specification, to see the full request response structure, as well as actually play with the API. And we do support code generation for the clients as well. So you can very quickly, copy and paste this into a terminal and get started that way as well. And that is a high-level overview of going from the API specification and the Stoplight design tool to the test functionality, where you tested the API specification, ensuring that the actual server itself and the spec are still in sync. We also have the mock functionality, and then lastly, that documentation component. So now this is ready for consumers and other stakeholders as part of this API that they can get started interfacing with it and understand the full request and response structures.
Awesome. Thanks for that, Ross. I appreciate it. So do you want to stop sharing and I'll share mine again?
Yep.
Awesome. Well, I appreciate that. And I appreciate everyone's time today and joining us for the webinar. So I will tell you, coming up for us is some great things for Stoplight and our platform. So I just wanted to share this last slide with you and sort of what's next for the Stoplight platform. So you'll see in the next few months the release of our new studio, including the modeling, design collaboration, and the validation, some of the things you've seen today, with the extension on our manager, giving you the ability to explore your own designs and create a catalog of those designs, some design governance, which will give you some shared style guides, duplication management, the idea of shared libraries and reporting and insights across those designs, and of course the hubs, which is you saw a little bit of a preview of the documentation. We'll be keeping that product and expanding that as well. So I appreciate your time today, and I just would invite you to come to our next webinar, which will highlight the rest of the platform. Thank you, everyone.